Hello, my name is Youjin Kong, and I'll be an assistant professor of philosophy at the University of Georgia beginning 2023. I'll be speaking today about intersectional fairness in AI. Let's start off with a little bit of background. As is well known, Joey Bonlamini and Timnit Gebru's groundbreaking work, Gender Shades, found that major face recognition algorithms fail to recognize about 3 out of 10 Black female faces. Not only did the algorithms perform better on recognizing men than recognizing women, which is sexism, and better on white people than Black people, which is racism, they yielded the worst accuracy on Black women, far worse than Black men and white women. This has been the paradigmatic example of the intersectionality of sexism and racism in AI. Intersectionality, a concept rooted in Black feminist thoughts and popularized by Kimberly Crenshaw, refers to the idea that racial, gender, and other forms of discrimination are not separated, but they intersect and operate together. This has been a gold standard in feminist research in the humanities and social sciences. As a philosopher who's worked on the notion of intersectionality, I was excited to see that Bonlamini and Gebru's work highlighted the need to extend intersectional approaches to AI fairness. They made it clear that if AI research examines bias only along the racism road or only along the sexism road, then it cannot tackle the bias that Black women experience at the intersection of the two roads. Now, a growing number of studies in computer science are using the concept of intersectionality for analyzing bias and improving fairness in AI. These studies often take fairness to be a matter of achieving statistical parity among intersectional subgroups. That is, an AI algorithm is intersectionally fair if the probability of its outcome is roughly the same across all subgroups defined by cross-cutting attributes. I call this dominant view of intersectional fairness PA, which stands for its two keywords, parity and attributes. For example, let's suppose a company uses an algorithm to predict who will be successful employees, and based on this prediction, makes hiring decisions. According to the dominant definition, this hiring algorithm is fair with respect to race, gender, and disability if each of these 8 subgroups, regardless of their intersecting combination of the attributes like race, gender, and disability, has the same probability of getting hired, say 30%. This sounds pretty straightforward. All applicants groups have a 30% chance of being hired, so every group has equal chances regardless of their race or gender. However, is such an algorithm really fair? Is this a useful framework to implement fairer AI for a fairer society? I argue that it is not. I identify and examine 3 fundamental problems with this dominant interpretation of fairness, so we can create better analytical frameworks for intersectionally fair AI. First, the dominant view is so preoccupied with the intersection of identity categories such as race, gender, and disability that it fails to address the intersection of oppression such as racism, sexism, and ableism. In the dominant interpretation, intersectionality is seen as a matter of splitting a group into finer subgroups along the lines of race, gender, class, and so on, or as AI researchers call them, protected attributes. However, I argue that this is a narrow interpretation of intersectionality. Black women are oppressed not because they have intersecting identities of Black and women per se, but because these identities are shaped by and lived in the intersecting structure of racism and sexism. This is not to say that AI fairness research should abandon the language of identity or attribute altogether. Instead, this is to say that identity should be examined in its relationship to power rather than as an independent unit of analysis in a vacuum. As an example, my paper discusses why face recognition algorithms are so bad at recognizing Black women. Possible reasons include training data sets with only few images of Black women, implicit bias among crowd workers and engineers, and the lack of diversity in big tech companies. All of these constitute the structure of US society and global AI market. Operation being a structure means, according to Iris Marion Young, who first conceptualized the operation as such, that all of these, like implicit bias and lack of diversity, these are not some abnormal things, but normalized processes of everyday life. At the core of intersectionality is the idea that racism, sexism, and other forms of oppression intersect to constitute such a structure. Focusing too much on generating fine-grained combinations of attributes, the dominant view diverts attention away from structural analysis. The dominant view's near exclusive focus on attributes leads to another problem. Is it sufficient to designate race and gender as protected attributes, or should racial gender groups be split into even finer subgroups along the lines of class, sexual orientation, disability, immigration status, and so on? In responding to this question, the dominant approach faces a dilemma. On the one hand, if a fairness standard pursues parity among all possible subgroups, it should keep splitting groups into smaller subgroups like Black women who are working class, queer, having disabilities, and so on, until the point where there is no group and the individual is the only cohesive unit of analysis. This way, the dominant view falls into an infinite regress. On the other hand, if a fairness standard pursues parity only between relevant subgroups, it's susceptible to the problem called fairness gerrymandering, namely, an arbitrary selection of protected attributes. Any selection of protected attributes can be regarded as arbitrary. For example, if a fairness standard requires parity among racial gender groups like Black women, Black men, white women, and white men, some people might say it's arbitrary not to designate disability as a protected attribute, and the list goes on. Many AI researchers argue that they can avoid this problem by considering only statistically meaningful subgroups that computers can identify. They say, for example, if race and gender make statistically meaningful difference in the outcome while disability does not, it's justifiable for the algorithm to enforce parity between Black women and other racial gender groups, but not further dividing each group into those with and without disabilities. However, I maintain that this kind of statistical turn does not resolve the gerrymandering or arbitrariness concern, because the question of what is relevant is itself a political battleground, not merely a statistical problem. To illustrate, let me read Shasha Cassandra Chalk's #TravelingWildTrans anecdote, where airport scanners falsely mark their non-binary body as risky. Cassandra Chalk writes, quote, "When I enter the scanner, the TSA operator is prompted by the UI to select male or female. Since my gender presentation is non-binary femme, usually the operator selects female. However, the three-dimensional contours of my body differ from the statistical norm of female bodies as understood by the dataset and risk algorithm. If the agent selects male, my breasts are large enough, statistically speaking, in comparison to the normative male body shape in the database to trigger a risk alert," end quote. What I argue this anecdote shows is that there's no such thing as non-binary gender in this algorithm in the first place. It labels humans as either female or male. So the problem is Non-binary has never been considered as a type of gender whose relevance can be statistically measured. It's an unobserved characteristic, a characteristic that matters in one's experiences of discrimination, but remains unobserved because socio-technical systems exclude it. Therefore, issues of relevance, or more precisely, what can be assessed as more or less relevant, and what is excluded even from the discussion of relevance, like non-binary in this example, these are political problems, not purely statistical ones that computers can identify and measure. Lastly, I argue that the dominant view fails to capture what it really means for AI algorithms to be fair in terms of both distributive and non-distributive fairness. The dominant view takes a distributive approach to fairness. Suppose a philosophy grad program in the US uses an AI algorithm to make admissions decisions. According to the dominant view, the algorithm is fair with respect to race and gender if it distributes admissions rates equally among racial gender groups. For example, if Black women, Black men, white women, and white men have equal chances of getting in, say 33%. However, there are cases in which unequal distribution is a more proper distribution. Philosophy is a largely white and male-dominated field, which might discourage Black female undergrads from applying to graduate programs. So suppose there are 30 white male applicants and 3 Black female applicants to this graduate program. According to the dominant view then, this algorithm is fair if 10 white men and 1 Black woman are likely to be accepted. Is it though really fair? It is not, because it reproduces the status quo and the representation of Black women. In order to actively mitigate the effects of systemic marginalization, the admissions algorithm might need to distribute a higher probability to Black women. So the point is, without attending to the structural pattern that privileges certain groups while marginalizing others, a mere equal probability distribution does not achieve fairness. In this regard, the dominant approach fails to address non-distributive aspects of fairness. It is the structure of racism, sexism, and other forms of oppression that shapes the unfair distributive patterns, such as the racial gender gaps and admissions rates. Also, non-material types of harm, like the stereotypical representation of women and people of color in Google search results, cannot be remedied by redistribution. I claim that AI fairness should be examined through the lens of non-distributive justice, as Iris Young puts it, the elimination of structural oppression. The key takeaway from my research is that we need to rethink the notion of AI fairness. We already know AI is biased, but mathematical technological solutions, such as enforcing statistical parity across the board, will not work to make it fair. This indicates that we need a different framework to understand and implement fairness in AI. I suggest distinguishing a strong sense of fairness from a weak sense and working towards that stronger fairness. By weak fairness, I refer to passively and retroactively debiasing the algorithm. This has been the focus of AI literature, which is captured by the build first, fix later approach. To be clear, the dominant approach that seeks to debias using unequal distribution among subgroups is a step forward to intersectional fairness in AI. However, I argue that this alone cannot make algorithms substantively fair as opposed to just formally fair. In that racial, gender, class, and other systemic oppression is reflected in and reproduced by AI algorithms, making algorithms substantively fair involves resisting and undermining the very systems of oppression that create biased AI in the first place. Therefore, AI fairness in a stronger sense means designing algorithms to actively and proactively challenge oppression and make society fairer. In this sense, strong fairness requires reframing the purpose of algorithms. For example, let's consider recidivism prediction algorithms, which are found to be biased against poor communities of color. What's the purpose of developing and using this algorithm anyway? Is it to put people in jail for more years and reproduce the current pattern of mass incarceration, or to change it? An important question to ask then is how we could redesign the algorithm to oppose the mass incarceration of poor people of color and systemic racial economic inequality. Thank you very much for your attention to this presentation. If you have any questions or comments, please feel free to reach out by email.